Hi, how you doing? Marco here. In my very first video, I'm going to show you something about the Model Context Protocol, MCP. What problem is solved by the protocol, and finally, how you can build your very own MCP server really easy. So stay tuned and let's get into it. If you are already familiar with the concept of MCP, you can find timestamps down below and skip ahead to the section you're more interested in. So let's look into the problem which is solved by the MCP protocol. If you ask ChatGPT, for example, to book a cheap flight on a certain date from, let's say, Munich to Los Angeles, he won't do that for you. Instead, he will give you the instruction that you can book your flight on your own on a certain airline or a site, which will compare every available airline for you. If you want to automate that, you may develop your own Python program. This could be like this. You have your Python program and you're using something like macro automation, which is the recording of your mouse movement, clicking and typing. So you can go to airline one, search for Munich to Los Angeles on a certain day, click on search, sort on the price and click on the cheapest one. And the Python program will do this over and over again. Doesn't scale well. So you can do as well something like web scraping, which is basically collecting the raw data from the website. But of course, you have a lot of airlines. You need to have a lot of storage and a lot of compute power. And lastly, the most common one, you could use something like APIs. But even with APIs, you have several challenges to solve. For example, the format of an API endpoint could be something like /API/flights. The second airline may use something like /v1/get flights for collecting a certain flight. And the third one may use something like flight-list. So you need to adapt your piece of code for every single possibility from an airline. And even the value you get back from the airline could differ. The first one may use a three-letter annotation, the second one the whole name, and the third one something in between, combining both. So you need to parse everything that and put it in structured data that you can compare every airline. Sounds like a lot of effort, right? So having something which will understand every data, no matter what is the format, would be a huge benefit. So what is coming to our mind, of course, is to use AI. So using this would need something like an AI agent. So what is an AI agent? A quick recap. An AI agent is a piece of software containing an LLM of your choice. And of course, having a memory that it can store data and recall information when it's needed to. And this agent will connect to several airlines via API. But then the developer of the AI agent need to program every API possibility to get every airline. So putting the load into the AI agent developer would be way too much. So we need something in between. This is where the Model Context Protocol comes into play. We are putting an MCP server in between the AI agent and the resources we want to access. So you need only a specific MCP server built for a specific purpose, for example, searching flights, build it once and reuse it multiple times. At this point, you may ask yourself, what is MCP and what is this dude talking about? So let's have a look into the MCP protocol. MCP has three components. The MCP host, which is basically your AI agent software or your application, and the MCP client, which is a part of your AI agent software. And this one will establish the connection and keep it alive. And you have, of course, the server, which will provide the context. What is the context? There are three primitives. For example, we have the tools, which are basically executable functions, for example, APIs. We have resources, which are which is data stored in a database or file on MCP Server, for example. And lastly, we have predefined prompts that you don't have to type it over and over again or do something stupid like having some prompts in a WordPad and copy pasting it between. Putting everything together would look something like this. You have your AI agent software like Cloud Desktop, LM Studio, Copilot Studio. You have your LLM of your choice, and the built-in clients are communicating with several servers. For example, the first server is giving you tools, the second one have a database in it you want to access, and the third one has your most frequent used prompts. And to have a real-world example, I've chosen a scenario with a Catalyst Center. We have a pre-built or specific for this purpose built a MCP server with two tools. The first tool is to assign a port on a certain switch managed by the Catalyst Center, and another tool translating the host name of a switch into the UUID, which is a unique ID given by the Catalyst Center to every switch managed by it. So if I ask my AI to assign a port on, let's say, edge 01, by default, he should look first into every MCP tool and the description of the tool if there is a tool which can be used to solve the problem. In our case, we have the port assignment. The AI will recognize that there is a tool and will read the description, and you will find out that this is the perfect tool to do the task, but we only have the name of the switch, but the tool needs this unique ID. So he will go again respectively and go search for the next tool and will find a tool for translating the name into the ID. So he will call this tool, putting in the name of the switch, getting the ID, and after that putting everything together, because now we have all the data and all the information it is needed to do the task, and calling the port assignment tool, putting in the ID of the switch, the interface we want to configure, the VLAN, and maybe the .1x authentication type. The AI agent will call this tool, and the tool will fire up the API call on the Catalyst Center, and the Catalyst Center will configure our desired switch port. Perfect. Now we have the theory. Let's get our hands dirty. What we want to do now is to have MCP server based on a very small Python code. So what we are going to do is to create a small Python code collecting all the data managed by the Catalyst Center and working with the data. To do this, I've prepared a certain code. So this is a very simple code using a Catalyst Center SDK to access the Catalyst Center and collect the information from all devices. So if we go ahead and just make a UV run main.py, we should go collecting all the information from every single device, returning it, and we should see this in a very short moment that we can get all the information from every switch out there. And there we go, we have all the information we need. To start creating your first MCP server, you can take any working code you may already use on a daily basis to do the task. So to start, we augmenting our code by a library which is called FastMCP. It's very convenient and easy to use. And to use it, we start by instantiating it and giving a name right away, which in my case is CatSenMCP. And whereas FastMCP really starts to shine is how easy to use. To get a primitive like tool, we just take our already working method and putting a decorator on top of it like mcp.tool. So we already have a tool configured. It will take the method and use this as a tool. And another very important concept is the concept of tool description, which is given by the docstring. If an AI agent is looking for the right tool, it will look into the description of every tool and decide based on this text whether it will use this tool or not. So the better your docstring is, the more likely the AI agent will use this tool on the right situation. So putting a docstring down there, in my case, is pretty easy. Tool for accessing Cisco devices over the Catalyst Center, former DNA center for the OG guys out there, and collecting something like device names, IP addresses, and so on. But we're not done right now. We need some more things. For example, we need to use annotations because the data format is very important. We need to specify or tell the fast MCP server which data is needed to give and what is coming back. So because this is a read-only scenario, we don't need to put into the method. We are just giving things back. And what we are giving back is a list. And within the list, we have something like a dict. And within the dictionary, we have the key value is a string. And the value within the dict could be any. Because as you can see, list, dict, and string is already included in the Python version, but any isn't. So we need to import any for the annotation. To do this, we need from typing import any. So at this moment, we can use any. And because the list we are getting back is not a raw dictionary, it is something called a mydict, which is specific for the SDK. So we need to take this, transform it to just a normal dictionary and putting back. To this, we will iterate through it. So getting the devices from the Catalyst Center, creating an empty list, going through every item, load it, convert it into JSON, and load it into JSON, and just return it. So our first tool is finished. So the last thing we have to do is just creating the main method. In the main method, you are doing also a very important thing. So you run the MCP server and specify the communication way. You can do something like Studio, STD, standard input output, but then you are using the local machine and everything has to be local. But I want to use it across a network, so I use streamable HTTP on a certain port and a log level of debug. So because we have configured everything now, we can start our server and test the server. To do this, we just run the code by uv run main.py. And in just a short moment, here we go, we can see that the server is up and running, fast MCP 2.0, and the server URL we are going to use. To test this, we can use something like the MCP inspector. It's free to use, you can download it and start it, and just put in the URL the MCP server gave us. Just click connect and we can see we are already connected, and there we have the primitives I explained earlier with resources, prompts, and tools. Because we write a tool, I'm going to click there and list all tools. Of course, we only have one tool configured, but if you click there, we can see that our docstring is now here, ready to be used. And if I run the tool, what happened now is that the MCP inspector was calling the tool on the MCP server, and the MCP server was firing up an API call to my lab environment. And we can see here it was successful, and there's even a response. And in the response, we can see that there's a structured content, and we can see everything on the lab. Of course, now we want to see an AI agent in action. To do this, I've chosen LM Studio because it's very easy to use, and within this program you can download your LLM of your choice. Everything basically which is on the most famous site, Hugging Face, you can download it and use it locally, completely air-gapped. So this is very important for a lot of you guys out there. So without further ado, let's go into LM Studio and preparing everything for it. I've chosen the OpenAI 20B model within the MLX version. The MLX version uses the Mac hardware architecture very efficient, so that I can get the most out of my laptop. And we need to specify the MCP. So for this, we can click on the small plug icon, click on install, and edit the mcp.json file. In this JSON file, you need to specify how the AI agent can reach and use the MCP server. So to do this, I paste in a predefined value. And you can see MCP server is the name of the MCP server, and because we have chosen tunable HTTP, you just need to specify again the URL, and that's it. So we're gonna save it, close it, and now if you can just click on it, restart, and we can see it has found the MCP server and collected all the tools. So he listed the tools and get the tools, and now we are ready to use it. Now the first thing we are going to ask is to list all devices managed by the Catalyst Center in a table by name, IP address, and iOS version. By default, the AI agent should now look into all of the MCP tools. By now, we only have one. Read the description and find out that he can solve the problem or the task, do the task which we have asked him to do by this specific tool. And as we can see, he wants to call it. We proceeded because we trust our own MCP server. And now the AI agent should call the tool. The MCP server will fire up the API call. The Catalyst Center should reply with all information. The MCP server will translate it into a language the AI will understand and sending it back. As soon as the AI agent will have all information, he will take it into prompt, and now he's trying to, thinking about it and create a response. So in just a short moment, we should start appearing a table with all the devices, with their names, IP addresses, and OS versions. So just a short moment later, and now we are seeing the table building up with exactly what we have asked for. Because we run our AI model locally on my MacBook, we need to take some consideration into mind. Of course, the privacy is great running it locally, but our resources are limited. So some example here is our context window after building the table from the gathered information is already over 60% full. So what I've done is something which is called context engineering. I asked the AI to take the table, filter it based on edge and border nodes that we can shrink down information to proceed faster, and creating a JSON file out of it. So basically, I can copy paste this into a notepad and proceed to the new window. With the new window, we have, of course, the full context window available again, but our information is lost. This is the reason why I copy paste the JSON code into a separate file that we can proceed. So to work with our new gathered data, I want to take it even further. We have the name, IP address, and iOS version of the devices. So I want to know if there's any known vulnerability for any of our used iOS versions in our network. For doing this, I've downloaded a new MCP server and augmented MCP.json file. So as you can see here, we can have multiple MCP servers simultaneously and even accessing them by different ways. Our own MCP server is accessed via URL, and the second one is accessed by doing the command on its own to start the server. So going back, we can see there is a new MCP server with two new tools, get CVE and search CVE. So of course, the next thing we are doing is asking the AI for any known CVEs. We take the data and we'll ask, is there any known CVE for our used iOS versions? List them with the description. option and paste the data we have collected already up to this point. So I've downloaded it from the internet. Of course, it's not safe. I've scanned the MCP server for any malicious code. I will cover how you can do this into my next video. And what's very important as well is to keep your AI agent to ask you. As you can see here, he will show you the data the AI agent will send to the MCP server. If there's any sensitive data in it, you should, of course, decline it. And you can also see here that you can edit the arguments. So because there is nothing wrong within this text, I can then proceed. I said proceed, and the agent, of course, will again search for any known CVEs. So he gather all the CVEs and bring me back as a table. After a short waiting time, we can see the final results. Actually, we find a CVE on the iOS version 16.6.1, which is to attack a switch with CDP to DOS it or get authentication to the switch. So the next thing we want to do is to ask the AI if we are even affected. Let's say we have a CB for the routing protocol BGP. If we don't use BGP, there's no reason to act immediately. So I want to double check if our devices are affected by reading the configuration. To do this, we are going back to our code and augment the code. For this, I want to use netmicro to SSH into the device, gathering the information or the running configuration and working with it. So I have imported netmicro and adding another tool. This is done really easy, so just a really simple tool. And this time, you can see that we are actually giving something into the MCP server. So it is expecting a variable called host, and it is a string, and we are getting back a string. You can see again a very important doc string, putting in an IP address to SSH into a device, username and password already present in the tool, and he will get back the running configuration. And with this, he should get all the informations we need. After restarting the server, we can now see that there is one more tool, get device config. So what I want to do now is go and see if we are affected by the CVE of 16.6.1 by getting the device config. This should be enough to go on a device, search for the running configuration, getting the device configuration and search for it. So if you don't be that deep into iOS networking, CDP is enabled by default. So if you cannot find the CDP command in the configuration, means that it's actually configured. So this is some kind of intelligence the AI needs to do. So after a short moment again, we can see that the AI was calling the get device configuration tool, getting the configuration, double thinking about what he have found and compare the running configuration with the CVE. And as we can see, he knows already that CDP is enabled by default and there was no CDP run or with globally or per interface. So he starts to think about, okay, no CDP is not in the configuration, so it's actually enabled. And so because it's enabled, we are actually affected. And even I don't ask it for it, but he gives me some recommendations for remediations or mitigations. You can see either upgrade it to a newer version which don't contain the CVE, for example 16.6.3, disable it globally or something else. So this is a really great way for a real world example. You can work with your database if you have a controller like a Catalyst Center playing around with all the information and can ask further questions which are building up one question by another. So getting the information from the switches, searching for vulnerabilities, and even double checking if we are affected is a really great example how you can leverage MCP protocol. And I think it's a very good reason why you should start thinking, building your own MCP server, start to gain knowledge about it, and think about how you can use it in your daily job, because MCP protocol is there and it's very valuable. And I think now is the perfect time to get started with this protocol. Thank you for watching this video, and I hope you enjoyed it.